and will be available on our website. So I'll now hand over to Martin and Emma.
Thanks, Gerard. Thanks for joining us today. I'm Emma Shuttleworth, so I'm kicking the talk off. So Gerard introduced us as Protect, but that's actually shorthand for a longer project title, which is Optimising Natural Flood Management in Headwater Catchments, Protect Downstream Communities. You can't get a decent acronym out of that, so we just chose Protect. So I'm going to talk you through a little bit of background to the project, and then some of our preliminary results before I hand over to Martin. So Protect is a group of academics and practitioners based at the University of Manchester, Newcastle University, University of Leeds, and also then we've got Moors for the Future Partnership and the Environment Agency as our key project partners. So you might be wondering why we're focusing on headwaters. So demonstrating NFM impacts at large catchment scales is difficult. This is because NFM can often only make up a small proportion of the catchment, and there are other catchment factors varying, making it difficult to pick out the NFM signal. So headwater catchments offer a unique opportunity to really control for those other catchment factors and focus on the NFM work, so we can develop understanding of changes in runoff processes and demonstrate catchment scale benefits by scaling up. Another reason why upland headwaters are interesting is because upland restoration work is often funded outside of the flood defence budgets. A lot of moorland restoration is for things like water quality, biodiversity improvements, so they're not always accounted for in our understanding of NFM assets. And we have the opportunity to enhance NFM delivery by optimising these restoration management works that were already going to happen anyway. They're typically kind of low value areas, heavily managed as well, so it doesn't matter if maybe they become a bit wetter or have some different management practices on them. So our project objectives for Protect are to derive empirical evidence of the impacts of upland restoration and management techniques. It includes sphagnum planting on previously bare sites and species dominated sites, different kinds of gully blocking design and spacing, looking at woodland sites, woodlands planting in steep sided cloughs, and also looking at the longer term of these NFM measures to see how the NFM impact to see if we can have long-term NFM impacts from these measures. This empirical evidence will be fed into a model, so that's our colleagues at the University of Newcastle, predicting the impacts of NFM measures at the larger scale. And we're going to firstly ground truth this model in Glossop, which is one of the 22 communities at risk on the eastern edge of Greater Manchester, which were identified by the Environment Agency as being at risk of flooding. So we're going to use Glossop as the test case and then apply the model to these other communities at risk. We're also going to collate data on existing restoration works across the UK and potential. So apply the model there as well to see if the restoration work has had any NFM benefits. And finally, we're going to use all of this to provide practical policy guidance on the planning and implementation of NFM in upland areas. Okay, so a little kind of bit of background about upland peatlands in the UK. Peat forming landscapes covering about 60% of the uplands in the UK. Highly productive of runoff, so these are kind of wet environments. The whole reason we have peat there is because we've got a lot of water. They also store a lot of water, they've got high water tables, so they're quite quick to produce runoff when it rains. In the UK is that peatlands are also quite badly degraded. So you've got a lot of bare peat flats, you've got a lot of deeply incised gullies running through them. John Tallis to term them the badlands of Britain. And these bare surfaces can quickly lead to the evacuation of water from hill slopes and the delivery of water downstream. So although these would be quite flashy environments anyway, they're even flashier due to this degradation. Why does this matter? So here's a little picture of Glossop, test catchment, and you can see that Glossop there is lying right down at the bottom of steep clough valleys with a lot of peatlands up on the plateau. And when it rains, Glossop floods. Picture from 2002. It's not just a recent phenomenon though, this is going back to 1940s. And Glossop is typical of these catchments on the edge of upland areas, relatively small, built-up area, might not traditionally be the focus of large-scale hard engineering works to reduce flooding. So NFM, through upland restoration, offers an opportunity to reduce the flood risk in these flood-prone areas. And it's not all bad because these peatlands are being restored. In the UK, we've got a history of about the last 15, 20 years. Peatland restoration has been growing in popularity. And this takes the form of things like reseeding with a utility grass. So that's the kind of grass you just see on your lawn. So not necessarily the kind of vegetation that would naturally grow there, but it's quick growing and it can bind eroding surfaces together and kind of halt that degradation. It can only grow there by changing the chemical properties. So you have to apply lime to increase pH and a bit of fertiliser. And the idea is that this is a relatively short-term application of these things. The grass grows, stabilises the surface, and then through time, the natural vegetation has a chance to return. Also things like gully blocking, which is damming up these erosional channels to try to take some of the energy out of water flowing through them. And kind of more recently, the focus has turned to sphagnum planting. So trying to return some of the kind of keystone species to these areas. Sorry, I can see a lot of things popping up. Is everyone okay? And can you see my slides and hear me okay? I don't quite have a chance to see.
It seems some people are not seeing the slides, but others are. They look fine to me. I don't know what the problem is. I think we'll just have to carry on.
Seem fine with me.
Okay, I can see a lot of them now saying fine. I'm going to have to push ahead just because otherwise we might not get through everything. Okay, I'll keep going. So yeah, that's kind of the restoration in these upland areas, and it's once it takes hold, it's a relatively rapid process. You can see there on the left from 2010, 2011. So before some of this moorland restoration was applied to this area, and then the photos on the right are taken from the same angle, and you can see just the scale of the change in over only 4 years, and then an extra kind of 4 years after that. You can see the system's really changing and maturing. Vegetation there, possibly a bit more wetter. So how might this impact downstream flood risk? So that's one of the things Protect is setting out to try and find out. Protect follows on from some work we did earlier, making space for water, with More to the Future partnership. And one of the first jobs we did once we got funding for Protect was actually produce the results from the precursor work. So Making Space for Water was a DEFRA-funded project. Demonstrate that land management changes in catchments can contribute to the reduction of flood risk, whilst also delivering a range of other ecosystem services. Making Space for Water was focused on biodiversity, sediment production, water quality, but most importantly, water quantity. Where did this happen? So in the Peak District, for those of you familiar with the area, it's Kinder Edge. And we had 3 small test catchments, kind of like hectare scale catchments. Higher Edge was revegetated, but then some of our catchments didn't just have that treatment. You can see that red rectangle, an area that was left as a bare control. And so that's so we could assess any additional benefits from business as usual. We had the revegetated catchment, and we also had the catchment that was revegetated and gully blocked. So by setting it up like that, we were able to see the impacts of various different kinds of peatland restoration on NFM. This is what Kinder Edge looked like before the treatment in 2009, and this is what it looks like today. So hopefully you can see quite a stark change there, and hopefully you can also see that little patch of brown, which is the bit that was left as bare control. So you can see that's what the entirety of Kinder Edge would still look like if Moors for the Future hadn't intervened. And what effect did this have on flow? So if you look at the hydrographs in the top left-hand corner there, you can see the upper leftmost image. All the hydrographs in the 3 catchments were behaving the same before restoration went ahead. And then after restoration, you can see that there has been a distinct shift at the 2 treatment catchments. So the red one is the control catchment, the green line is the catchment that was just revegetated, and the blue line represents the catchment that was revegetated and gully blocked. And you can see at the 2 treatment catchments, we've seen a reduction in peak flow and an increase in lag time. You can see also that by adding gully blocks to a revegetated system, you get extra benefits on top of revegetating alone. If you now move your focus over to the right-hand side, so those point graphs, that can give you an idea of the scale and magnitude of the change. So all the points are represented as relative to control. The green blocks represent the revegetated catchment. The blue blocks represent the revegetated and gully block catchment. And I think the most striking change you can see there is lag time. So that's kind of the figure A over on the right-hand side. So after restoration by revegetation, lag times doubled at the treatment catchment, and then they actually tripled compared to the control in the revegetated and gully block catchment. Similar kind of, maybe not quite as striking reductions in peak flow, but we reduced peak flows by about 25% with just revegetation alone, and about 50% with revegetation and gully blocking combined. Interestingly, if you look at the very bottom rightmost diagram, you'll see there was no change in percentage runoff. Although we've seen increases in lag and reductions in peak flow, we haven't actually seen any changes in the volume of rainfall that's becoming channel flow. So the same volume of water is still leaving the peatlands, just doing so at a reduced rate. I think that is linked to the surface roughness increases, the vegetation and gully blocking. So you increase surface roughness on the hill slopes through the revegetation, and then you get that additional channel roughness benefit from the gully blocking. So that's what we learned from Making Space for Water. That was a precursor to Protect. What we're doing now as part of Protect. So same area up on Kinder Edge has seen significant sphagnum planting starting in 2015. So we're using the same micro catchments to look at the impacts of sphagnum planting, kind of like the gold standard, I suppose, in terms of peatland restoration. So we've got 9 years now of rainfall runoff data up on those sites, and in 2015, 36,000 sphagnum plugs were planted, and I think there has been significantly more planting in the years since, especially in our revegetated and gully blocked catchment, which has had really intensive plug planting, especially in flow pathways, to kind of like supercharge the restoration and try to speed up any impacts. I'm going to talk about the results from that in a little bit. Also want to draw your attention to the fact that we are also working with More to the Future on some work reintroducing sphagnum to species dominated sites. So sites dominated. So Kinder was once upon a time bare peat, all that restoration through nurse crop of grass, whereas these sites have intact vegetation. It's just potentially not you might want growing on that piece of moorland. So can we bring sphagnum back to those landscapes? So areas dominated by Calouna or Molinia, cotton grass, and what impact might that have on the NFM benefits? More Life 2020, those sites were established in 2017. I should have edited this. Sphagnum planting took place earlier this year. There was a slight delay because of the drought last summer. So we don't really have any after data to share with you yet. So that's a bit of a watch this space in terms of the species dominated sites. But I can give you an update of what's happening with those once bare peat sites. So here's just a nice picture to show you how the sphagnum's taken. So you can hopefully see in that middle picture, in the flow lines, there's some quite nice green flushes, which is where sphagnum's taken, and we've got some zoomed in images over on the right there where you can see how the sphagnum has spread in those flow pathways. So we know in theory that this should be having a positive impact in terms of flood risk, based on some work, plot scale work from Joe Holden at Leeds, which showed that flow rates over sphagnum were slowest compared to other vegetation types and bare peat, and also some modelling work which has shown that sphagnum should slow the flow, but it's important where in the catchment this sphagnum is planted, which is why we've focused on those flow lines. And in practice, we have seen additional benefits. So if you have a look on the left, you can see hydrographs from the same sites. Again, red represents the bare control. Green is the revegetated site, which didn't have any sphagnum planting, I should say. And blue represents the gully block site that has also had sphagnum planted on it. So that's that gold standard. If you look over on the right, you can see kind of the magnitude of these changes. Seen additional increases in lag time at the site that's had sphagnum planted, whereas we haven't seen any increases in lag time at the site that's only had revegetation and no further change. You can see there's also some further small reductions in peak flow, but interestingly, there are also some reductions in peak flow at the revegetated site, and that might be due to the fact that we're seeing the nurse crop develop more into natural vegetation sorts, so more interesting vegetation, I suppose, and potentially some increased roughness there. I'm going to leave that there. If you've got any questions about sphagnum and runoff, please do ask them later. Hand over to Martin now.
Thanks, Emma. Good afternoon, everybody. So I'm going to pick up on some of the initial data from the field experiments that we've been building as part of Protect. So Emma's talked about one type of optimization of restoration for NFM and demonstrated that if we add sphagnum into revegetated sites, that's giving us some additional benefit. But we also wanted to look at the nature of gully blocking and whether different types of gully block might allow us to optimize the change in the timing of flow of water off these restored sites. So we've been setting up a couple of experiments to test, well, it says 4 designs on the right hand side there. We'll probably do rather more than that now because we've added in some peat dams that we're going to look at, as well as the stone dams that you can see drawn there and the various designs of wooden dam. So we're going to look at different gully blocking types, and we're going to look at different gully blocking spacings. And next slide, please, Emma. Thank you. We're going to do this at a couple of locations. So we've been monitoring a site called URCHIN, which is near to the summit of Snake Pass in the Peat District. So that's URCHIN on the left-hand side. And what we've been doing here is installing lots of small V-notch weirs, like you can see in the centre, which have discharge monitoring, which is telemetered via a radio system like the one on the right there. And we've instrumented a dozen weirs on URCHIN Clough. So we've got 12 subcatchments, each of which is a similar kind of scale to the 3 that we were looking at previously on top of Kinder Scout. Next slide, please. Our second site for doing this type of work is over a little bit further north and a bit further west above Staley Bridge, again east of Manchester, and this work is being carried out on the site of the Staley Bridge fire from a couple of summers ago. So as you can see on the left hand side, a fairly substantial area of moorland was burnt. That was in places fairly heavily gullied, and we've installed another 10 weirs across the Staley Bridge site. We've been collecting data for 12 to 18 months at URCHIN Clough, a rather shorter period of time at Staley Bridge. We're in the all of this experiment, as Emma has previously shown you with the Kinder Scout work, is set up according to a before-after control intervention design. So critically, we collect before data so that we understand the way our catchments are working before we intervene. We keep a control site where we don't do anything, and then we compare the response of the intervention sites relative to the control before and after the intervention. So we've been in the phase of collecting before data at these 2 sites, and the plan is for the gully blocking to go ahead at these sites hopefully this winter. But what I can present to you is some interesting findings that come out of looking at the before data, and particularly in relation to the variability of the system. So if you were going to criticise the that we presented in the top half of this presentation, you'd say, well, that's all very well, but n equals 1. You've got one control site, one catchment that was treated by revegetation, one microcatchment that was treated by revegetation and gully blocking. What do we know about natural variability? And so we've been learning things about natural variability from the much larger number of sites we've been studying through the Protect project. And there are differences in sites. The ones that we looked at on Kinder Scout were very severely eroded, a lot of bare peat exposed both in the catchment and on the gully floors. At URCHIN Clough, many of the gullies are perhaps more typical of eroded gully systems across upland Britain. They're eroded, but there's some partial revegetation going on. So we have the opportunity to look at that. Next slide, please, Emma. And just as an example of the degree of variability that we might see, this is Storm BRONAGH, which was one of the bigger storms from last winter. This is discharge from the 12 URCHIN Clough sites on the left-hand side, and you can see they're behaving relatively similarly. The lag times don't vary much. They do at a couple of sites, but they're all flashy moorland systems. But some fairly significant differences in peak discharge across that range of naturally revegetating gully systems. And just for reference, on the right-hand side here, this is again for Storm BRONAGH, and these are the catchments Emma was showing you previously. So the red one is the control site on Kinder, the green one is the revegetated site on Kinder, and the blue one is revegetated and gully blocked. And for comparison, the brown one is a relatively intact system close to URCHIN CLOUGH. So you can see that as you start to look at more than a single site or a very closely matched set of sites, as we had on Kinder, there is more natural variability in the system. So next slide, please, Anna. We thought we'd have a look at trying to explain that. We looked at, you might logically think that the more vegetated systems might be reacting rather differently. That doesn't seem to be the case. There's no very significant trends in lag time or peak discharge according to how well revegetated the gullies are. But next slide, please. When we looked at catchment area, we could see that there were some very apparent scale effects. So lag times, as you might expect, are longer in the larger catchments. But interestingly, storm discharges relative to area are also lower in the larger catchments. So what does that mean in terms of what we might expect to see when we begin to intervene on these systems? Next slide, please. So what we're looking at here is the same plot that you were looking at previously. So we've got catchment area plotted on the x-axis here, lag time on the left on the y-axis, peak storm discharge on the right. The black dots here are the untreated, naturally revegetated sites from URCHIN CLOUGH. And what we've done here now is just superimposed the blue, the green and the red are the three sites that Emma was discussing previously from Kinder. So if we look at the left-hand side, for example, you see that very short lag times that Emma described for the red site, which is the bare peat control. The lag times are rather longer for the revegetated site on Kinder, which is the green dot, and significantly longer for the blue dot, which is revegetated and gully blocked. And reassuringly, in a way, that the green dot falls kind of within the range of the black dots, which so that the revegetated site on Kinder, the treatment site, looks like the naturally revegetating sites at URCHIN CLOUGH. I think the key thing about this diagram is that the blue dot, revegetated and gully blocked, sits significantly above that main trend. And so what we would kind of hypothesize for this is that what we're looking to do when we intervene on these systems is to move the black dotted line somewhere up towards the red dotted line. We would expect to be able, across that range of different catchment sizes, to be able to increase lag time. Next slide, please, Emma. Okay, so just to wrap up some of what we've described so far, the preliminary data shows that we can significantly impact storm flow runoff from blanket peat sites when we revegetate and when we gully block. We get longer lag times, we get decreased peak flows. We don't get very significant changes in runoff, so we think the key thing that's going on here is a slowing of the hill slope flow, probably due to increased hydraulic roughness on those hill slopes, rather than a very significant storage effect. We need to do a bit more on that, particularly looking at more sites that have had sphagnum addition, so that we can figure out, because the sphagnum addition site on Kinder is also the site with gully blocks, there's a possibility that we're seeing a mixed effect there of sphagnum addition and the maturing of the gully blocks. And so we've got some ongoing work to try and pick that apart. But pre-intervention data on the PROTECT project, we're seeing that these naturally recovering systems are quite variable, that it doesn't seem to be the case that gully floor vegetation is driving this. And that suggests to us that when we see an impact of revegetation on Kinder Scout, it's actually the revegetation of the hill slopes and the slowing the flow of the hill slopes that's probably important. And the additional effect of gully blocking probably relates to changes in flow velocities in the channels. So we think gully blocking has the potential to further attenuate the flow in these systems, and when we begin to block at the URCHIN, CLOUGH and Staley Bridge sites this winter, that's what we hope and expect to see. Next slide, please, Emma. Okay, now I saw somebody earlier on when Emma was presenting the kind of changes in peak discharge pop up a question saying, kind of, does this matter in terms of downstream infrastructure? Are these changes in runoff and peak discharge relevant in terms of the downstream property protection? And of course, that's what PROTECT ultimately is going to try to look at. The changes that Emma was presenting in the first half of this presentation relate to kind of small 1 hectare-ish upland catchments, but the communities at risk that we're interested in the context of this work are those that sit downstream of extensive areas of moorland, like Glossop on the left-hand side here, where catchment areas are perhaps 10, 20 square kilometres. For the Making Space for Water data, Dave Millage at Newcastle did some modelling work to try and upscale the impact of doing that type of revegetation and gully blocking work across a larger proportion of the catchment and to model the effect at larger scales. Dave was able to show in the upper Ashop catchment, which drains off Kinder Scout to the east, actually the opposite direction to Glossop, basically what he did was apply the observed changes to, I think, 12% of the catchment to see what impact that would have at the scale of the upper Ashop, which is about a 10 square kilometre catchment. So it's a significant upscaling, not quite to the scale of the Glossop catchment, but much more comparable. Next slide, please, Emma. So conceptually, what we're trying to do is, at the top, the red bit of the catchment is degraded, the green bit is relatively undegraded. We're trying to restore the degraded bit, change the hydrograph from the degraded portion of the catchment so that the combined hydrograph from the whole catchment is impacted, and we see a reduction in peak discharge on the black line, which is the combined discharge. Next slide, please, Emma. So these are the results that Dave Millage produced for the upper Ashop catchment as we went from half a hectare to 9 square kilometres, and we modified 12% of the catchment. We found that revegetation was reducing peak discharge by up to 5%. Revegetation and gully blocking was giving us up to 8%, and Dave was confident that we were certainly getting kind of 2 to 4% at the 9 kilometre squared catchment scale. So the initial kind of outcomes suggested, yes, that this could work. PROTECT is going to take this modelling work an awful lot further. Next slide, please, Emma. And actually validate the model much further for Glossop, as Emma suggested earlier. So the image on the left, I think, kind of illustrates the problem perfectly. That's Glossop. It's got 3 main drainages, which are tributary around the centre of Glossop. They are largely moorland drainages, they're very flashy systems. That's why the catchment is so prone to flooding. So we're looking to refine our modelling for the Glossop catchment. We've got lots of discharge measurement now within Glossop, so that we can model actual storms within the Glossop catchment to refine the modelling approach, and we will then apply that model to a further set of moorland catchments that drain to the 22 communities at risk that Emma referred to earlier. Okay, next slide. that are ongoing. We're about just about halfway through Protect now. It's a 4-year project. We're just about 2 years in. So a lot of the effort to date has been on setting up those major field sites and collecting the before data. Other parts of the project that are coming on stream will involve looking at the long-term sustainability of some of these interventions. So, for example, as gully blocks mature, infill and revegetate over a period of time, what impact does that have on flow velocities through the gully systems? We'll be picking that up as part of the project. We'll be doing some experimental work to understand how water transitions from hill slopes into gullies, to consider whether that's an important part of slowing the flow from these systems. And we have some work looking at the impacts of woodland planting in upland areas on infiltration and runoff. Next slide, please, Emma. We've already looked at. Other things which are kind of ongoing and coming soon. Tim Allett, as part of the project, has led on producing the report on the left, peatland catchments and natural management for the IUCN as part of their peatland programme as a contribution to their revised commission of inquiry. That was presented at the IUCN conference relatively recently and soon to be published. I don't know whether Tim could tell us when, but it's on its way. Like many of us, I guess, the project has also input into the select committee call for evidence on the state of peatlands. And we are expecting, although yet to be confirmed, that Emma will be giving oral evidence to the select committee before long, when they figure out when they're doing it. And we have a couple of papers in draft, which when they begin to appear, will alert you in the newsletter. One on the model development and one beginning to outline some of the work on natural variability that I've discussed so far today. And I think that's it. Thank you for listening. Any questions, it says.
Great, thanks, Martin and Emma. As I said, we've had some beforehand, so perhaps if I ask you a couple of those. Actually, I thought I could probably lump some of them together. There were several that dealt with wider benefits and impacts, so around water quality, biodiversity, carbon storage and sequestration, and erosion and sediment transport. Apologies, that's probably a rather big question, but could you deal with to what extent the work deals with those wider issues?
Protect is not looking at those issues explicitly, because effectively what we're doing is accepting that is why a lot of this moorland restoration work is going on, and picking up on whether we can optimize that work to deliver both the carbon and water benefits, but also something on NFM. Having said that, we've previously done lots of work on carbon fluxes and biodiversity change and those other co-benefits that come from moorland restoration. We published some work last year looking at kind of trajectories of change in response to revegetation. And there are some things that we definitely know. So, for example, the revegetation and gully blocking work clearly has a dramatic impact on particulate carbon losses from these systems. So effectively what you do is you shut down the erosion of organic material from the surfaces, and so you stop losing particulate peat from the catchments. And those changes are a couple of orders of magnitude, so they're really quite dramatic. The evidence is much less clear on dissolved carbon losses. That's perhaps unsurprising because most of this work doesn't raise water tables back to the surface. If you're dealing with 2-3 metre deep gullies, the gully blocks are not 2 or 3 metres deep, they're 50 centimetres deep. So the impacts on water table around the gullies are relatively small. Although we do see some minor increases in.
I've got a cat interested in NFM.
Sorry?
There's a cat interested in NFM.
Yeah, sorry, that was at this end. I have now thrown him out. So water table rises associated with gully blocking are relatively small. We see water table rises associated with revegetation, but they're also significant, but not anything close to a complete restoration. So we don't see much in the way of dissolved organic carbon shifts, which is what we would expect. Biodiversity comes back quite nicely to comparable to pristine systems.
I can include links to all of those papers and reports and things with the materials we send out after the webinar if people are interested.
Yeah, great. We can put those on the website.
Gerald, could we pick up next the last question that just came in, which was about sponges storing water? And I also noticed that somebody earlier on asked about infiltration. I think that's probably quite an important point to pick up. And effectively, I think the answer to those questions is that we don't see very significant changes in storage, I don't think, because these are blanket peatlands where water table is naturally very close to the surface. Even in degraded systems, the amount of additional storage there is really rather small. And so when it rains, you rapidly fill up the limited amount of storage and you generate overland flow. That's why these systems are so flashy. And so this work is probably not having a very significant, well, it may have an impact on infiltration at the surface. That infiltration is not then supporting large amounts of soil water storage because there isn't much physical space for soil water storage in the system. A slightly more open question is whether really extensive deep sphagnum cover would give us some element of sponge. Most kind of UK blanket peatlands, well, maybe less so in Scotland, but certainly most English blanket peatlands have relatively little sphagnum on them. And so we don't see much kind of water storage in sphagnum. As the sphagnum matures on the kinder sites, it will be interesting to see whether any element of that water storage within the cellular structure of the sphagnum returns. But we've argued for a while that the sponge is not really an appropriate analogy for these type of moorlands.
Thanks, Martin. Another couple of questions were around the topic of maintenance and the longevity of NFM measures, and whether longer term maintenance, what extent that's needed, and how much thought's been put into how it might work.
I think the maintenance primarily would refer to gully blocks. We have a number of types of gully block that we will be trialling. The best evidence that I guess we have to date refers to the stone dams. The stone dams, I would expect, require relatively little maintenance. Some of the pictures that Emma showed in the first third of the presentation showed stone dams that very rapidly become revegetated, such that almost the gullies look like wet flushes. Those wet flushes are partly held in place. Yeah, so the bottom right of that slide, by those big stone dams at the base of them, those aren't systems I would anticipate requiring much, if anything, in the way of maintenance. More interesting is the kind of slot dams. So if as part of our work we are able to demonstrate that, for example, the letterbox type slot dam gully blocks that Dave Millage has designed, which are optimized for NFM, if those turn out to be the most effective solution, then there becomes a question over what the timescales of preservation of those gully blocks are in the landscape. And then we get into questions of whether we build them out of plastic piling or whether we build them out of timber. The piling probably, well, certainly there are plastic piling blocks that look as good as new near to the summit of Snake Pass that have been there for nearly 15 years. So those probably have rather longer longevity than some of the wooden systems. So the short answer to the question is that these gully blocking programs for the Protect project are going in this winter. So there's no explicit maintenance associated with them, because in the lifetime of the project, obviously they will be fine. But depending on which type of blocks turn out to be optimum, that may or may not be an important consideration.
Okay, thank you. Another question was around, you did talk a bit about this, the scaling up of your work to understand what wider catchment processes, and also can you say anything about how the work is transferable to informing flood risk management in other areas of the country, perhaps?
Well, the scaling up is what the modelling is for. That's what we're trying to do, and that's the modelling part of the project only started 12 months ago. So Dave and Sal, who is the postdoc on that, are kind of in the process of building and calibrating the model at the moment. So we probably should have much more to say about that in perhaps in another webinar in 12 or 18 months' time. They do have some initial results that suggest that our kind of hypothesis that slowing of flow across hill slope surfaces is what's driving these responses that we see at the catchment level, does seem to make sense within the modelling framework. In terms of how applicable is this to other parts of the country, much of the upland peatland of the UK is gullied. It rather depends whether you say how much of the upland surface is gully or how much of it is impacted by gullies. But figures of kind of 20, 30, 40% of upland Britain, upland peatlands in Britain being gullied are perfectly reasonable. What is different probably from the Kinder Scout example is the degree to which these are completely bare peat. Kinder and Bleaklow and areas of the Southern Pennines were the most severely eroded blanket peatland systems in the UK, with lots of those kind of deep, bare gully systems. Other parts of the UK probably have more evidence of gully systems with partial revegetation, and perhaps looking a bit more like some of the URCHIN CLOUGH sites, which is why they're going to work on partially revegetated systems and understanding the impact of that, and then understanding what happens if you block those systems as part of Protect is important. So I would expect that this should be applicable more widely.
Okay, thank you. Are there any, there's quite a few questions come in. Are there any that had caught your imagination? Give you an opportunity to expand on what you've said.
Any of these you want to pick up on whilst I scan through?
Well, while you're looking, there were a couple of questions around woodland planting. I know you've talked a bit about cloughs, and somebody's pointed out that historically these areas would have been forested. And has any consideration been, if you thought at all about that as an option, what sort of more
And just there's
forestation?
another question here about, is further succession to a tree community desirable in some cases? So trees, yeah, the woodland clough planting is obviously already happening across a lot of these areas, and that's why part of the project will be looking at the impact of infiltration changes associated with woodland in those kind of contexts. That's ongoing. We don't have results from that yet. Question about whether what we want to see is a succession to trees here is an interesting one, because it kind of relates to what you think you want your uplands to look like. So it's as much a societal question as a NFM question, I suspect. Trees are beginning to grow.
Kind of taps into the. Oh, sorry, Martin.
Sorry.
I was just going to say, it kind of taps into the rewilding debate there.
Yeah.
Kind of like, how far back do you rewild to? And also kind of like what the trade-offs for your ecosystem services you want as well. These might be ideal for people who want lynx roaming the UK uplands. Potentially not ideal for water companies who want to regulate runoff through peatlands, so water quality through peatlands.
So at the base of these peatlands are fairly substantial pine stumps in many areas, and you find bits of silver birch through the profile in places. And it is the case that the trees are beginning to naturally spontaneous germinate in parts of the landscape where grazing has been restricted. So, you know, and forested bogs are normal across much of the Northern Hemisphere. So you could go that way. But as Emma pointed out, we expect our upland bogs to do lots of different things for us. And there'll probably be as many views on whether we should reforest them or allow them to reforest as there are services they provide.
Okay.
The bottom has just noted that a range of pressures, what does it say? Yeah, pressures being reduced. And somebody much further up the thread asked the question about why are these systems bare and gullied in the first place, and the answer to that is probably a combined impact over the last millennium of fire and overgrazing, chronic air pollution, as the last questioner identified. Quite a lot of those pressures through economic change or conservation intent are receding, which is why many of these systems are showing significant spontaneous natural revegetation. But equally, there are very large areas where the type of excellent work that Moors and the North Yorks Peatland Partnership and the North Pennines Peatland Partnership have been doing, have been, accelerating that transition.
Thank you. We've just got about 2.5 minutes left. Is there anything you'd like to say by way of conclusion, or any sort of burning question that you've spotted that you think deserves an answer now?
Gosh.
I guess from my point of view, it's a bit of a watch this space. We're only 2 years into the project. We've presented some of our preliminary results and some of our previous results. So, there's a hell of a lot more to come out of this. And we look forward to sharing our data with you in the future towards the end of the project.
I guess there are quite a lot of questions on the right-hand side, and we haven't been able to get to all of them, and we probably didn't get to all of the ones that were pre-submitted either. Gerard, would it make, if we were to capture these and write some brief notes in response to them, is there a way to share them with everybody?
Yeah, well, we can share them on the website. Good idea.
We'll do that then.
Well, we'd better start drawing to a close then. Thanks very much, Martin and Emma. Emma, could you go on to the next slide, please?
Got to go right the way down to the bottom, sorry.
Fresh.
Too far.
Yep, great. Thank you. Yeah, so just to tie things up then, yeah, if you have got any questions that come to mind afterwards, or that you'd like to send us, please do email us. You can see there's the program email address and the Protect. It doesn't matter, use either of those, and we'll pull together a response in the document that Martin suggested. Anything else as well? But this is the first time we've run the WebEx. Any suggestions or feedback on how it's gone for you, how we might improve? That would be very welcome. As I said at the beginning, we will make the recording of this available on the website. The next webinar is on the 27th of November, and it's on farmers and soil management with Niels Caulfield, and you can find out more about that on the website. Registration is now open, so I hope you'll be interested to join us again for that. Finally, we do have a newsletter. We've had one issue out in July, and we're working on the next one. You can sign up for that and see the existing issue on the website again. So just to say thanks very much for joining us, and hopefully we'll meet up again soon. Good.
Everyone.
Thank you.